All right, so we are going to talk about the review for this unit. So, first off, whoop, I have this in the wrong spot. Here we go. First off, what is a mole? So, a mole is basically just a number, right? So, like a dozen means 12. A mole means 6.022 times 10 to the 23rd. Okay, now, a dozen can be 12 anything, right? You can have a dozen eggs, a dozen donuts, a dozen people, a dozen desks. Okay, it's the same with a mole. You can have a mole of anything. Now, granted, a mole is a much, 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 much bigger number than a dozen. So, really, realistically, you can't have a mole of a lot of things because there just aren't that many of those things that exist. But in theory, you could if they existed. So, this enormously big number we use this to count atoms and molecules because atoms and molecules are really, 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 really ridiculously small. And that's why we need a really, 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 really ridiculously big number to count them. So that is the long and short of it of what a mole is. All right, so atomic mass versus molar mass. So atomic mass is the mass that one particle of a substance weighs in AMUs, or atomic mass units. So what I mean by particle is an atom or a molecule. Okay, so if I have one atom of carbon, it weighs 12.01 AMUs. Okay, now molar mass is how much one mole of a substance weighs in grams. So if we have 6.022 times 10 to the 23rd atoms of carbon, it will still weigh 12.01, but it will not weigh 12.01 AMUs. It will weigh 12.01 grams. Okay, so that's the difference between atomic mass and molar mass. Atomic mass measures one particle, molar mass measures one mole. Okay, so to determine the molar mass of a substance, we have to find the molar mass of the different elements in the substance in the periodic table. So nitric acid, HNO3. We have to find H, N, and O. Whoop, that's the wrong thing. Here we go. Here's H, here's N, here's O. So H is 1.008, N is 14.01, O is 16.00. So we write those down. 1.008, 14.01, and 16.00. There is one hydrogen, there is one nitrogen, and there are 3 oxygens. So we have to multiply that oxygen's molar mass by 3. So we multiply all those together, we add them all up, and we get 63.02. Now, the units for the molar mass is grams per mole, because that is how many grams 1 mole of nitric acid weighs. So that's the unit, gram per mole. Okay. Now, ammonium nitrate, NH4HNO3. So these are the same elements as our last one, so we don't even have to worry about looking them up. So we have N, which is 14.01. We have H, which is 1.008. And we have O, which is 16.00. There are 2 N's. There are 5 H's. There are 3 O's. Okay, so we multiply all those together. We add them all up, and we get 81.07 grams per mole. Okay. All right. Last one, same situation, but this time we do actually have different elements. So C, which is 12.01, H, 1.008, N, 14.01, O, 16.00, and S, I'm going to have a hard time fitting this in, but 32.07. Okay. C, there are 7 of them. H, there are 5 of them. N, there is 1 of them. O, there are 3 of them. And S, there is 1 of them. We multiply all those together, we add everything up, and we get 183.20 grams per mole. Okay? All right, so moving on to actual conversions, okay? So we're going to start with our particle conversions. So particles are atoms, molecules, and formula units, okay? All of which I've told you guys in the past you can shorten to part, okay? So every one of these conversions, we start by writing down our given. So our given is 1.51 times 10 to the 15th atoms. So I'm going to write atoms this time. But you can write particles if you would like. Whoops, not really sure how that happened. We put that over 1. We do our conversion factor. We need atoms on bottom so that atoms cancels out. Our very first step every time, I'm sorry, not our very first step, our very first conversion factor. Our very first step is writing down the given, but our first conversion factor every time is converting to moles, unless you start with moles, which we did not start with moles, so we need to convert to moles, okay? Now, the number that goes in front of moles every time is 1. The number that goes in front of particles every time is 6.022 times 10. Oh, that's a really bad x. To the 23rd. Atoms cancel out. We're left with moles. That is where we want to be. So now we just do our math. So we do 1.51 times 10 to the 15th divided by 6.022 times 10 to the 23rd. We get 2.51 times 10 to the negative 9th. And we've got to make sure we put our units, moles. Okay. Next, we have, oh, there we go. 4.25 times 10 to the negative 2 moles. Put that over 1. We do our conversion factor. Moles on the bottom so that it cancels out. We are converting to molecules. Remember, our first conversion factor every time is going to moles unless we start with moles. So we're starting with moles this time, so we don't have to convert to moles. So now we can just convert to molecules, which we can call particles. So we can shorten it. 1 goes in front of moles. 6.022 times 10 to the 23rd goes in front of particles. Moles cancel out. So we take 4.25 times 10 to the negative 2 multiplied by 6.022 times 10 to the 23rd. And we get 2.56 times 10 to the 22nd particles. All right, next one, 7.952 moles over 1. We put our moles on bottom. Our first conversion factor is always to moles, but we are starting with moles, so we can just go right to formula units. So we're going to call that particles. 1 goes next to moles. 6.022 times 10 to the 23rd goes next to particles. Moles cancel out. So we multiply those two together. We get 4.79 times 10 to the 24th particles. All right, last one, 5.90 moles of calcium, converting to atoms. We put it over 1. We do our conversion factor. Moles on bottom, atoms on top, or particles. 1 goes next to moles. 6.022 goes next to atoms. Moles cancel out. We're left with atoms. So we which is where we want to be. Whoops. So we multiply those together. We get 3.55 times 10 to the 24th particles. Okay. So now, whoops. So now we're doing mass conversions, okay? So we started out the exact same way. We write out our given. 3.50 moles over 1. We do our conversion factor. Moles goes on bottom. Our first conversion factor is always to moles, unless we're starting with moles. Since we're starting with moles, we can just go to whatever we need to go to. So we put grams on top. 1 goes next to moles. Now, what goes next to grams? Well, the thing that goes next to grams changes every time. Okay, so whatever the molar mass of LiO2, sorry about that, of LiO2 goes next to grams. Okay, so we add Li, multiply by 2, we add oxygen, or when we add oxygen to that, and we get 29.88 grams. Okay, moles cancel out. We are left with grams. So now we multiply those two together and we get 105 grams. Okay. Next, we start with 7.65 grams over 1. Our first conversion factor is always to moles. So grams on bottom, moles on top, 1 next to grams. And then the molar mass of CO2 next to moles. So that's 44.01. Grams cancel out. We are left with moles. That is where we want to be. So now, since 44.01 is on the bottom, we have to divide that instead of multiply. So 7.65 divided by 44.01 equals 0.174 moles. All right. Next, 5.62 grams over 1. We put grams on bottom. Our first conversion factor is always to moles, unless we're starting with moles, which we're not. We put 1 next to moles. We put the molar mass of Kr next to grams. That turns out to be 83.80. Grams cancel out. We're left with moles. That is where we want to be. So now we do our math. Again, we're going to divide. So we're going to get 0.0671 moles. Excuse me. Last one. 0.0050. Oh, nope, that's not right. 0.0550 moles over 1. We do our conversion factor. Moles, we are going to grams. 1 next to moles. Molar mass of AS, which is 74.92. Moles cancel out. We're left with grams, which is where we want to be. So now we multiply. We get 4.12 moles. Excuse me. All right, there we go for that. So next, we have volume. Okay, so volume is another different conversion factor, but we start the exact same way. We write our given, 84.6 liters over 1. We do our conversion factor, liters on bottom. Our very first conversion is always to moles, so we put moles on top. 1 goes next to moles. Now, the number that goes next to liters, the conversion factor for liters to moles is 22.4 liters equals 1 mole. So we already got the 1 mole part. So now we just do 22.4 liters. Liters cancels out. We're left with moles, which is where we want to be. So now we just do our math. 84.6 divided by 22.4. That equals 3.78 moles. Okay. Next one, 2.53 moles. And we're converting that to liters. So we do our conversion factor. Okay, moles on bottom. We can go from moles to liters. 1 goes next to moles. 22.4 goes next to liters. Moles cancel out. So now we just take 2.53 times 22.4, and we get 56.7 liters. And that's it for that. Now we're going to mix it up a little bit. We're going to do a whole bunch of different ones. Okay. So we got to identify what we're starting with. We're going to identify what we're going to end with. Okay. So we start with our given 4.22 times 10 to the 15th atoms or particles over 1. We do our conversion factor. Atoms goes on bottom. Our first conversion is always to moles, unless we start with moles, which we did not. So moles goes on top. 1 goes next to moles always. 6.022 goes next to particles always. Atoms cancel out. We're left with moles. That is not where we want to be, so we need another conversion factor. Moles goes on bottom. Grams goes on top. 1 goes next to moles, and the molar mass of U goes next to grams. So that turns out to be 238.03. So we take our numbers on top and we multiply them together, and we get 1.004, and there's more numbers, but I'm not going to write them. Oh, that's supposed to be a dot, 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 times 10 to the, oh man, my pen is not working correctly right now. Times 10, there we go, to the 18th. And then on the bottom, we have 6.022 times 10, oh my gosh, to the 23rd. We divide those two, and we get for our final answer 1.67 times 10 to the -6th grams. Okay, for those of you that are not super great at scientific notation, that is the same as saying 5 zeros, 167 grams. Okay. All right, so next one, 8.65 times 10 to the 25th molecules of H2O, and we're going to liters of water vapor. So we start off with our given, 8.65 times 10 to the 25th over 1. Oh, not equals. We do our conversion factor. Oh, and I forgot to put units. Bad Roth. Molecules, so that's going to be particles. Okay, so we put particles on the bottom so that it cancels out. Okay, our first conversion factor is always to moles, unless we start with moles, which we are not. So we put moles there. We put a 1 in front of moles. We put 6.022. Oh my gosh, my pen is not working right today. 0.022 times 10 to the 23rd Okay, particles cancels out. We're left with moles. That is not where we want to be, so we need another conversion factor. Okay, moles goes on bottom to cancel out. We are converting to liters, so we put that on top. 1 goes next to moles. 22.4 goes next to liters. Moles cancels out. We're left with liters. That is where we want to be, so we don't need any more conversion factors. So we multiply all our top numbers, and we get 1.9376 times 10 to the 27th. Our bottom number is 6.022 times 10 to the 23rd. Okay, we divide those two numbers and we get a final answer of 3,220 liters. All right, so next we have 84.57 grams of Fe2O3 to molecules. So we put our given 84.57 grams. We do that over 1. We do our conversion factor. Grams goes on bottom, so it cancels out. Our first conversion factor is always to moles. Okay, 1 goes in front of moles. The molar mass of Fe2O3 goes in front of grams, and that is 159.7. Grams cancels out. We're left with moles. That is not where we want to be, so we need to do another conversion factor. Moles on the bottom to cancel out moles. We are going to molecules, so we put that on top. We're just going to put particles, though. 1 goes next to moles. 6.022 times 10 to the 23rd goes next to particles. Moles cancels out. We're left with particles. That is where we want to be. So now we do our math. We multiply our top numbers, 84.57 times 6.022 times 10 to the 23rd, and we get 5.09 times 10 to the 25th. Our bottom number is 159.7. We divide those two, and we get for a final answer of 3.19 times 10 to the 23rd particles. Okay, last one. 14.44 grams to liters of CH4, sorry. So we put that over 1. We do our conversion factor. Grams goes on the bottom to cancel out. Moles is our first conversion factor. We put a 1 next to moles. We put our molar mass next to grams, which our molar mass is 16.042. Okay, grams cancels out. We are left with moles. That is not where we want to be, so we need another conversion factor. Moles goes on bottom. We are converting to liters, so that goes on top. 1 goes next to moles. 22.4 goes next to liters. Moles cancel out. We're left with liters. That is where we want to be. So now we do our math. We multiply our top numbers. So 14.44 times 22.4. We get 23.456 divided by 16.042. We divide those and we get 20.2 liters. And that is that.